In states of matter, the first state we are going to discuss here is gaseous state. We know that about the gases in earlier lecture we have discussed, and we have did the comparative study between the solid, liquid, and gaseous states. How the molecules are arranged, how molecules of the substance or the matters they will get behave in the three different states of the matter. And out of this, in gaseous state, we have discussed the gaseous molecules. These are just loosely bound to each others. There is no intermolecular force of attraction. So we can say that there is no van der Waals forces of attractions. These are separated in the empty space. Okay, the molecules are free to move to or the container. If you fill into the container, they can try to occupy the each and every corner, each and every place which is available into that container. Okay, they will try to occupy. Okay, that is the behavior of the gaseous molecules. As they are loosely bounded, intermolecular distance is more, as they are less denser, and due to the less forces of attractions and with the greater kinetic energy. Okay, they don't have the definite shape and definite volume. They will they are try to take the space or the volume of the system, okay, in which these are present. Okay, this is the overall about the gases. So how we can characterize these gases, or how we can measure, or how we can determine the gases or the properties of the gases? Everywhere when you are talking about the gases, generally we are talking about the its a volume, its temperature, its pressure, okay, and number of moles. So before this, in last lecture also we have comparatively discussed the properties of solid, liquid, and gases. In out of that, expansibility is the one of the characteristics property which are shown by the gaseous molecules. We know that gases can expand, okay, unlimitedly, in which place or in each vessels these are present, until and unless the volume capacity of that vessel it will not get filled, the gases they will try to expand. Okay, that means gases have the limitless, unlimitless expansibility, okay, as compared to the solids and liquid. Okay, that means expansion of the gases it is unlimited. Second is the compressibility. We have discussed gases can be compressed with the help of the application of the pressure and the pistons in the cylinder. Okay, through this we can carry out the compression of the gaseous molecules. That means with the application of the pressures, what will happen? As the gases, it will get compressed, volume it will be get decrease. Okay, whatever the volume you are getting, that after the compression with the help of the pressure, that will be the actual volume of that gaseous molecules. Next is the diffusivity. We know that. What do you mean diffusion? Okay, in diffusions, the molecules of the gases they will easily get diffused, and as they have the capacity to get diffuse easily, they will get mixed easily and homogeneously with the other gases. Okay, so when the diffusion is takes place between the gaseous molecules, they will form the homogeneous mixture with the other gases. Okay, next is the pressure. The molecules of the gas or the gaseous substance which are present into the vessels or the container, what happen? These gaseous molecules, they will exert the pressure on the wall of that container. Let us take the example of the balloon. If you are filling the air into the balloon or the gas into the balloon, what will happen? The expansion of that balloon is takes place. What will happen? The volume of that balloon it will get decreased, sorry, increased. Okay, so the volume of balloon it is get increased means what happen at the wall, at the surface of that balloon, what you are getting, the tense. Okay, it will fill the pressurized. So what is this? This is the pressure which is exerted by the gaseous molecules which are present inside that balloon and which are exerting this pressure on the wall of or surface of that balloon. Okay, that is the pressure which is exerted by the gaseous molecules which are present into the container. And you feel, if you check or if you try to check the pressure, is it we are getting the different pressure at the different place of that balloon? No. At the any surface in the any directions, if you check the pressure exerted by the gas or the air which is filled into that balloon, we are getting the similar pressure. That means gaseous molecules they will exert the equal and the same pressure in the all the directions or all the surface of that container. Okay, that is the about the pressure. Next is the what is the effect of the heat? We know that as the temperature increases, the again kinetic energy of the gaseous molecules it will get increased, and through this what happen? The expansion of the gaseous molecule is takes place. So as the expansion of the gaseous molecule is takes place means what? What will happen? The volume it will get increased. Okay, as the volume is get increased, what will happen? The pressure which is exerted by the pressure exerted by these gaseous molecules, it will get increased. Okay, in your childhood, you may have listened about the if you put the balloons into the temperature, okay, it will get burst. तुम्ही ऐकत होता की उन्हामध्ये जर तुम्ही फुगा ठेवला तर तो फुगा फुटला जातो. सो वाय तो फुगा का फुटतो? This is the reason behind this. That is the effect of the heat on the volume and pressure of the gas. Okay, these are the general characteristics of the gaseous states substance. Next is the parameters of the gas. Which parameters we can measure about the gas? As like we are measuring the parameters of other substance, that is solids. It's a weight, it's a volume. Okay, it's a surface area. So which parameters we can measure about the gas? The first parameters we can measure about the gas, it is none other, it is a volume. So volume of gas, we know that in which container the gas is present. Okay, and whatever the volume of that container, whatever the volume of that vessel, it will be the volume of gas. Okay, it is not different. In which vessel, in which container the gas is present and whatever the volume of that vessel or container, that will be the volume of gas. And it is indicated by the V. And how we can express the volume of gas? It is in the liter. Okay, the volume of gas, it is expressed into the liter or milliliter. Second is the pressure. So as in a 6th point I have discussed, and 6th and 5th point, the gaseous molecules they will exert the pressure on the wall of the vessels, and this pressure it will be depends upon the number of molecules which are present inside the vessel or inside the container. Okay, that is the pressure which is exerted by the gaseous molecules, and this pressure which is expressed, it is considered as a atmospheric pressure. Okay, generally we can talking about the 760 mm of Hg. It will be considered as the 1 atmospheric pressure at sea level. Okay, pressure is nothing but simply it is the force exerted by the impacts of its molecules per unit surface area of the container. Third is the temperature. Temperature, it is expressed in the degree Celsius and centigrade degree. We know that, and the SI unit of the temperature is the Kelvin. And we know that how to express the Kelvin. Kelvin is just degree Celsius plus 270 Okay, that is the SI unit of the temperature, and how temperature it will get affect, or how temperature it will influence on the behavior of the gas, like its volume and pressure we have discussed in earlier point. Next is the number of moles. Okay, number of moles of the gas into the container. So how you can express the number of moles of the gas which are present into the containers? Number of moles means what? How you can determine the number of moles of the gases molecules? It is just the mass of the gaseous molecules which are present into the container. And if you divide that mass of the gaseous molecule which are present into the container by its a molecular mass of the gas. Okay, that is the number of moles. It is just simply nothing but it is the ratio of the mass of the molecules to the molecular mass of the gaseous molecules, and this number of moles which are denoted by the N. Okay, so these are the some parameters of the gas we can study about the gas, like volume, pressure, temperature, and number of moles of the gaseous state. Next is the gas laws. So the various scientists, they have studied about the behavior of the gas, they have studied about the properties of the gas, and after observations, after investigations, they have put their observation and their conclusion in front of the us in the form of the laws. So these statements, or these predictions of the scientists, which are known as the gaseous laws. Okay, so we have discussed in the characteristics of the gaseous state. What happens? The volume of a given sample of gas. Okay, the volume of given sample of gas, it is depends upon the temperature and pressure which is applied to it. In first case, we have observed that if we increase the temperature, what happens? The volume of gas, it was increased. In second case, what happens? If you apply the pressure with the help of the pistons, what happens? The volume of gas, it will get decreased. That means what happens? It will get compressed. That is the compressibility of the gases. So that is the relationship between the volume, temperature, and pressure. So how the volume of the gas, it will get changed, or how the temperature and pressure, they will get affect on the volume of the gas, we'll discuss. And on this relationship, okay, on these three parameter, temperature, pressure, and volume of gas, and how volume it will get interchanged, how volume it will get changed due to the change in the temperature and the pressure which is applied on the gaseous substances. The scientists, after study, they have put the relationship between the volume, temperature, and the pressure in the form of the gaseous law. Okay, the gaseous law is just nothing but the relationship between the what are the four variables, four parameters which can express, which can explain the gaseous state. That is temperature, that is pressure, that is volume, and that is another is the number of moles of the gas. That the relationship between all these four variables of the gas, all these four parameters of the gas, it is known as the gas laws. So we'll discuss about the first law, that is Boyle's law. The scientist Boyle, Robert Boyles, in 1660. What you observe in the investigation, or in his experimental work, he observed that the volume of gas which was get changed by the change in the pressure, and the change in the volume, it was in such a way that as the pressure it was increased, what happened? The volume of that gas, say state, it was get decreased. So in between this, throughout the experiment, he observed that the temperature was constant. So he has concluded the statement and his observation put before to us, that is in the form of the Boyle's law statement. That is, at a constant temperature, the volume of fixed mass of gas is inversely proportional to its pressure. That is, temperature is constant and volume of fixed mass of gas, the mass of the gas which you are taking at the different pressure, it must be fixed. Okay, we may apply any pressure, that at any pressure, the mass of gas, say sample which you are going to take for the study purpose, it must be same. So it is an at a constant temperature, the volume of fixed mass of gas is inversely proportional to the pressure. That is, at a constant temperature, simply pressure increased, the volume decreased. Pressure decreased, the volume increased. That is, if the pressure is doubled, what happened? Volume, it will be half. Okay, simply the statement of Boyle's law. We can express this mathematically. That is, volume is inversely proportional to the pressure. So let us consider the volume of the gas, it is V, and the pressure, it is the P. So V is inversely proportional to the pressure at constant temperature. And N, that is number of moles, are also constant. Why? Because mass of gas, it is fixed. Okay, so according to the Boyle's law, volume is inversely proportional to the pressure at constant temperature and fixed number of mole, that is the fixed mass of the gas. So we can modify these equations again by using the constant to replace this proportional sign. V is equal to K into 1 upon P, or where K is just constant, so we can write this equation, PV is equal to K. Okay, this is the equations for the Boyle's law. Let's see in this picture. In the first picture, the volume of gas is the 1 liter and the pressure applied, it is the 1 atmosphere, that is the whatever the atmospheric pressure. Okay, we have not applied the any external or the excess pressure here. But if you apply the more pressure by increasing the pressure, what happens if you apply the 2 atmospheric pressure? 2 atmospheric pressure means it is the double as compared to what is the normal atmospheric pressure which is present on the surface of the gaseous molecules. So here we have doubled the pressures. That means simply we can say we have increased the pressure. So due to this increase in the pressure, what will happen? The gaseous molecules, they will get compressed. And the volume of this gas, it is get decreased. That is, let us see. In this first cylinder, we are getting the 1 liter volume. In second cylinder, we are getting the 0.5 liter volume. So what we can conclude? Increase in the pressure. What will happen? Decrease in the volume of the gas. Simply, volume is inversely proportional to the pressure which is applied on that container or on that vessel at constant temperature and fixed mass of the gas, that is fixed number of moles. Okay, we can express this graphically. Let us see, if we plot the volume in liter and the pressure applied in the mm of Hg, as the pressure is increased here, as the pressure is increased, the volume it is decreased. That is the graphical representation of the Boyle's law. If you plot the graph volume and the inverse of the pressure, it will show the straight line. Okay, that is Boyle's law. It's a graphical representation, it's a equation, it is quite simple. Second law is Charles' law. The scientist Charles has observed the relationship between the temperature, pressure, and volume in 1787. Okay, the Jacques Charles in 1787 he observed the relationship between the temperature, pressure, and volume. What he observed, when the pressure was constant, listen, when the pressure was constant, whatever the change in takes place in the volume of the gas, which are influenced by the temperature, and how this change in volumes are affected by the temperature, these are in proportional to the temperatures. So he stated that at a constant pressure, the volume of fixed mass of gas is directly proportional to the temperature of system or absolute temperature. Okay, so here it is written, at a constant pressure, the volume of fixed mass of gas is directly proportional to the Kelvin temperature of absolute temperature of the gas. Mathematically, we can express this relationship. Volume is directly proportional to the temperature at constant pressure and fixed mass of gas, that is the, again, N is constant. So how we can say that the relationship between the temperature and the volume, the temperature it will get double, the volume is also get double. Simply temperature increased, volume of gas is increased at constant temperature and number of, sorry, at constant pressure and number of moles when constant. Okay, again to replace this proportional sign, we can use the constant K. Okay, that is V is equal to KT, or the equation you may write phi upon T is equal to constant K. So we can get the value of K. Okay, so let's see here. The initially when the pressure is 1 atmosphere and volume of gas is 0.5 liter. Okay, but the temperature is 200 Kelvin. So if you provide the temperature to this cylinder, what will happen? The volume was get increased. The volume get double because we have doubled the temperature. Okay, that means by increasing the temperature of the cylinder or the vessel of the gas, what will happen? The volume of gas will get changed. Pressure is remains constant. Let's see. Pressure is remains constant, 1 atmosphere. There is at all no change in the pressure. Just due to the temperature, what happened? The volume of gas, it will get increased. That is the expansion is takes place. That is the expansibility of the gaseous molecules. Okay, as per the Charles law, temperature increase, volume it will get increase at constant pressure and constant number of moles. We can plot this graph, that is the volume and the temperature. Let us see. Initially at, as soon as we are increasing the temperature, what will happen? The volume of gas it is increasing. Initially here the less volume, as the at 100 we are getting the more volume. Okay, that is the, we are getting the straight line and we are getting the direct relationship between the temperature and volume. Okay, next is the Gay Lussac's law. So Gay Lucic law, it was given by the scientist Joseph J Lucic in 1802. Okay, the J Lucic has simply given the relationship between the pressure and temperature. So here the J Lucic law states that at the constant volume, the pressure of the fixed mass of the gas is directly proportional to the Kelvin temperature or absolute temperature. Okay, pressure and temperature. What are the relationship between the pressure and temperature which was given by the J Lucic? Okay, at constant volume. So again, we can mathematically express pressure is directly proportional to the temperature, and I have explained the why pressure it is get changed or it will get changed due to the temperature, that is in the 6 form. It is the effect of the heat on the gaseous molecules. So mathematically Gaseous law it will be explained as a P is directly proportional to the T when volume and n, that is number of moles, are constants. Again, we can use the constant P is equal to Kt, or we can write P upon T is equal to K. Okay, that is Gay Lucic law. It is just simply relationship between the pressure and temperature at constant volume. Next law of the gas, that is the Avogadro's law. You might have listened about the Avogadro's numbers. So in the experiment, if you take, earlierly at the start of the lecture also I explained about the balloon. If you take the balloon which is containing the mass of the gas, and if you add the more mass of the gas into that balloon at a constant temperature and the pressure, let us listen carefully. Yeah? The temperature and the pressure was constant. Still we are going to add the mass of the gas into that balloon. Till we are getting the increase in the, earlierly what we have studied, the volume was get increased by increasing the temperature and decreasing the pressure. But here temperature and the pressure are constant. We are just adding the number of moles with the mass of the gas. And with the addition of this mass of the gas, we are adding the mass of gas means we are adding the number of moles into that balloon. And due to the addition of number of moles of the gas into the balloon at a constant temperature and the pressure, what happened? The volume of balloon, the volume of gas, it will get increased. And this relationship which was put by the scientist Avogadro. Okay, so we can write this mathematically, or we can say that the amount of gas in the mole is proportional to the volume. Okay, we can write V is directly proportional to the N, that is number of mole at constant temperature and pressure. That is volume of gas is directly proportional to the number of moles of the gas which are present into the container or vessel at constant temperature and pressure. Again, we can use the constant here A. A stands for the Avogadro's constant or Avogadro's number. Okay, that is proportionality constant. Let us see here. Atmospheric pressure 24. If you add the gas, what happens due to the addition of the gases, that is more moles of the gas volume, it will get increased constant temperature and pressure. That is about the Avogadro's law. That is about the four gas law. First law is Boyles law. In Boyles law, the relationship between the volume and pressure at constant temperature. In Charles law, the relationship between the volume and temperature at constant pressure. In J Lucic law, the relationship between the what? Pressure and temperature at constant volume. And in the Avogadro's law, the relationship between the volume and number of moles of gas at constant temperature and pressure. Can we combine all these four laws? Because we know that in all these laws, the volume is the common. In all these four laws, the volume is common. In first law, volume is inversely proportional to the pressure. In second law, volume is directly proportional to temperature. In the Avogadro's law, the volume is directly proportional to the N, that is the number of moles. So we can combine because we have the common term, we have the common variable, common parameter in all these laws is volume. So we can write these three equations or the three laws in the one combined equation. As per the Boyles law, volume is inversely proportional to pressure. As per Charles law, volume is directly proportional to temperature. And as per Avogadro's law, volume is directly proportional to the N. Okay, these are the constant variables. Okay, as but it depends upon the conditions of that individual law. So there is three laws can be combined into the single more general law, that is general gas law. We can write it. Let us see. Volume. Volume is directly proportional to the N as per the Avogadro's law. Volume is directly proportional to the temperature as per Charles' law. Volume is inversely proportional to the pressure as per Boyle's law. That is here in this equation first. We will get the all three laws in the one combined law. Okay, we'll replace this proportionality signs, and for this we'll use again one constant. Okay, we'll see the equation which is coming after replacing the this proportional sign. And this equation first, listen carefully, this equation first, it is known as, it is called as the universal gas law. Okay, also called as the ideal gas law, and it will be applied to the all gases which will exhibit the ideal behavior, that is which are obeys the gaseous law, Boyle's law, Charles law, Avogadro's law perfectly. Okay, this equation first, V is directly proportional to the N T upon P, or V is directly proportional to the number of moles and temperature and inversely proportional to the pressure. This law, these equations, this expression is known as the universal gas law or ideal gas law. So how you can state that ideal gas law, or what will be the statement of ideal gas law? The statement is the volume of a given amount of gas is directly proportional to the number of moles of gas, directly proportional to the temperature, and inversely proportional to the pressure. Understood this equation first? So on the basis of equation first, we can state that ideal gas law or universal gas law here. Okay. Again, to replace the proportional sign and insert the constant in the equation 1, we can write V is equal to RNT upon P. Okay, where again we can, by simple mathematical operation, we can write the PV is equal to nRT. We know that PV is equal to nRT. This equation 2, R is the ideal gas, called as the ideal gas equation, or simply the general gas equation. You might have studied into the 11th, 12th or the 10th. Okay, PV is equal to nRT. It will be the equations for the ideal gas of the general gas equation. R is called as the gas constant. Okay, so the ideal gas equation holds the fairly accurately for all gases at low pressure. Okay, the pressure must be low, and if the number of moles which are present into the system, that is value of N, if it is 1, we can reduce or we can rewrite this equation, so we can modify the number of moles of the gas, or the value of N is equal to 1, the equation it will becomes the PV is equal to RT. Okay, so the ideal gas equation is called as the equation of state for a gas. Why it is called as the equation of state for a gas? Means whenever the substance which is present in the gaseous state, okay, it will be explained or it will be expressed by the ideal gas equation, that is PV is equal to nRT. Why it is called as the equation of state for the gas? Because we know that the way all parameters and all the variables which are required for the explain or to express the gaseous state of the molecules, it is the temperature, pressure, volume, and number of moles. And from these equations, let us see, we are getting temperature, getting, we are getting pressure, getting, we are getting volumes, getting, we are getting number of moles, getting. That means all the parameters, all the variables which are required to explain the gas, we are getting from the ideal gas equation, that is PV is equal to nRT. That's why it is called as the equation of state for a gas. Okay, this is overall about the ideal gas equation. Okay, next important point is the kinetic molecular theory of the gas. Kinetic molecular theory of gas. So what do you mean kinetics? What do you mean molecules? Okay, kinetics means we can say that simply it is related to the motions. And the motions which are shown by the molecules, we can call it is and the kinetic molecules. So which types of the molecules? The molecules of the gas. So simply it is in the behavior of the gases molecules which is in the random motions. It is known as the kinetic molecular theory of the gas. So scientist Maxwell and Boltzmann in 1859 develop the mathematical theory to explain the behavior of the gases and the gas laws. Okay, now explain the behavior of the gases and gas law. And it totally depends on the fundamental concept that gas is made of large number of molecules in the perpetual motions. That is, the gaseous molecules which are in the specific types of the motions. And these perpetual motions, that actual motion of the gaseous molecules, which was explained by the kinetic molecular theory of the gas. Hence, this theory is called as the kinetic molecular theory, or simply the kinetic theory of the gas, because the word kinetics implies the motion, as I have explained at the start, that is kinetic molecular theory of the gas. Why it is called as the kinetic molecular theory of the gas? Because it is the just due to the kinetic motions or the random motions of the gaseous molecules which are present into the systems. Okay, and these random motions or that perpetual motion of the gaseous molecules which was observed by this Maxwell and Boltzmann, and they have put in the form of the kinetic molecular theory. Okay, then which assumptions which are considered and which assumptions which are discussed in the kinetic molecular theory of gases, that is the assumptions of the kinetic molecular theory. First assumption, it is the first important assumption of the kinetic molecular theory is a gas consists of the extremely small discrete particles called as the molecule dispersed throughout the containers. Okay, we know that the gaseous molecules have the less interparticular distance or intermolecular force of attractions. So what happens? These molecules of the gas, they will get dispersed into the vessel, into the container in which we have put. That means if the volume of the gas, actual volume of the gas, if it is less, they will try to occupy. Okay, they will try to reach each and every empty space of that container and the vessels. So what we can say that the gaseous molecules, they will get dispersed. Dispersed means up to what extent they will get dispersed? As per the volume of that vessel or the container in which these gaseous molecules which are present. Okay, this is the first assumption of the kinetic molecular theory. That is, the molecules of the gas or the particles, they will get dispersed throughout the container. Okay, second assumption is that the gaseous molecules are in the constant random motions with the high velocity. We have discussed this. They move in the straight line with the uniform velocities and change the directions on collisions with the other molecules or the wall of the containers. So as the gaseous molecules are in the random motions, or as these are in the Brownian motions, and generally they are moving in the straight line. Okay, they are moving in the straight line. All the gaseous molecules, they can move. They are showing the kinetic motions, they are showing the random motion in the straight line form. But what happened? We are filling these gaseous molecules into the container. So as these are present into the container, they have the limitations about their motions. They have the limitations about their volume. They can move in the straight line directions until and unless they are not getting the obstacles. Okay, so situation may rise. Molecules of the gas which are moving in the straight line, they will get the obstacles for their motions, that is in the form of the wall of the vessels or wall of the container. So what happens when they get stuck up with the container walls, or when they will get hit on the wall of the container? So what happen? The direction of the molecules, it will get changed. This is the one possibility. Second is the molecules of the gas, they will get hit in between them. Okay, so there may be chances, that is the due to the molecular collisions also. What happen? The direction of the gaseous molecules, it will get changed. That is, the gaseous molecules, as they are moving in the random motions with the high velocity, their direction, it will get changed due to the molecular collisions and due to the collisions with the wall of the container. This is the very important assumption of the kinetic molecular theory of the gas. Okay, this is again second important assumption of the kinetic molecular theory of the gas. Third assumption of the kinetic molecular theory of the gas is the gaseous molecules which are present into the vessels. We know that the distance between the gaseous molecule is very large. This is the fundamental properties of the gaseous molecules, as we have discussed, as compared to the solid, liquid, and the gases. And the distance between the molecules, as it is very large. And the second also we have discussed, that is there is a negligible force of attractions between the gaseous molecules. So as per this kinetic molecules theory, they told that it is assumed that van der Waals force of attraction between the gaseous molecules does not exist. Do not exist the attractive forces between the gaseous molecules. So as there is no attractive forces between the gaseous molecules are free to move. There is no obstacles. Nothing is there to bound together the gaseous molecules. Nothing force, not any situation, not any force, not any how do you can say that? Any restriction is there which can bound together, which can restrict the movement of the gaseous molecules, so that these molecules are free to move anywhere in the empty space. Okay, that is nothing but the gaseous molecules which are independent to the other molecules which are present into the system. Why? Because the more interparticular distance and more distance which is present between the gaseous molecules, and very important is the negligible or absence of van der Waals forces of attraction between the gaseous molecules. Okay, this is the very important assumptions of the kinetic molecular theory of the gas. Next assumption of kinetic molecular theory of the gas is all collisions are perfectly elastic. Hence, there is no loss of the kinetic energy of a molecule during a collisions. As the whatever the collisions which are takes place in the elastic way. Okay, these are not plastic, or these are not in the any other types. So why these are elastic way? These are ready to change their directions, and as they are easily get change the directions, there is no need to utilize the more energy. The directions or the work is get done easily. There is no need to the provide the any additional energy, or there is no need to the utilization of the any additional energy. So what happen? The no loss in the kinetic energy of the molecules during the collisions, because the collisions they will get formed easily. Collisions, they are in the elastic in nature. So why kinetic energy is not reduced? Why there is a we are not getting the loss in the kinetic energy in the molecular collision? Because of the elastic nature of the collisions. Next is the pressure of the gas is caused by the heats recorded by the molecules on the wall of the containers. So in earlier also I have told the example of the balloons, the gaseous molecule, they will get hit. Okay, they will get attack on the wall or the surface of the balloons. So due to this, what happen? the pressure which was exerted on that surface, or the, what you can say, that wall of that balloon, so more specifically the wall of the container. Okay, this is related to the pressure, why pressure is exerted by, why pressure is generated by, why we are getting the pressure into the gaseous molecules. This is again very important assumptions of the kinetic molecular theory, which is related to the pressure. Okay, next is the gaseous molecules, they are showing the average kinetic energy. And we know that the equations of the kinetic energy is 1 half mE square. Okay, so whatever the kinetic energy of the gaseous molecules which are shown by this is directly proportional to the temperature. Okay, why it is directly proportional to the temperature? Because we know that the expansion of the gaseous molecule, it will be takes by the temperature. As the temperature increase, the more expansion it will be get takes place into the molecules of the gas. In solubility of the gas in liquid also we have discussed this point. Why the solubility of the gaseous molecules, it will get decreased into the liquid by increasing the temperature. Okay, because the kinetic molecular energy, or the kinetic energy of the gaseous molecule, it is directly proportional to the absolute temperature. And as the temperature increases, what happen? The kinetic energy of molecules, it will get increased. Okay, so the implies that the average kinetic energy of the molecule is the same at a given temperature. That means if the temperature is the same, the kinetic energy, it will be same. Okay, at various places. That means kinetic energy is directly proportional to the temperature. This is also very important assumptions regarding to the kinetic molecular theory of the gas. Okay, so simply we can say that energy is conserved in these collisions, although one molecules may gain energy and the expense of the others. Also, we can say that energy distributed among the molecules in a fashion known as the Maxwell-Boltzmann distributions. Maxwell-Boltzmann distributions. So one more assumptions, we can say that the molecules or the particles are in the rapid, random, and the constant straight line motions, well defined, and established laws of motion can be described these motions. Also, regarding the first assumptions, simply we can say that these particles are dimensionless points which occupy zero volume. So we'll see these assumptions in the one. Let us see here the random kinetic motions or the random collisions which are takes place into the gaseous states in the kinetic molecular theory of the gases. Let's see the gaseous molecules, they are moving in the random motions. Okay, their kinetic motion as they are moving the straight line. Let's see, until and unless this gaseous molecule, it is not get on the collisions, or it will not get attack, or it will not get hit on the any other molecules or the wall of the surface, it is not changing is the directions. Let's see these molecules, it is coming from the here it will get attack where the collision between the molecules of the gas, it is takes place and it has changed is the directions. Okay, at a constant motion is remains same. It has changed the directions, the direction of the motion due to the collision between these intermolecules. And second is the molecules, they will get when they will get hit on this wall or the surface of the vessel, again they have get change their directions. Okay, this is the have fun about their random motions of the kinetic motion of the gaseous molecules. And let us assume as these gaseous molecules, due to this random motion, due to this we can say that Brownian motions in the any directions, as they are getting hit on the wall or this surface of the container, what happened due to this such types of the hittings by these molecules of the gas, we are feeling the pressure at this surface, so any surface we are getting the feel of the pressure which are exerted by these gaseous molecules. Why this pressure is exerted by these gaseous molecules? Because these gaseous molecules, they are hitting. Okay, they are hitting on this wall or the surface of the container or the vessel of this or wall of this vessel. So to this continuous random attack or the random hit by the gaseous molecules, what will happen? The pressure will get exerted on the wall of the vessel or wall of the container. This is about the pressure. So by this pictorial representation, we can clearly get the idea about the pressure, about the volume, about the random motions, how the directions of the gaseous molecules it will get changed. That is the we can clearly understood about the kinetic molecular theory of the gas. So more clearly, let's see here in this picture. Okay, so here the gaseous molecules which are randomly present. Okay, randomly present here. Let's see the distance between the molecules of the gases. We are getting the too much distance between the molecules of the gases. Okay, so and let's see, this is the volume of the vessels. So here gaseous molecule is present here. So any area, any space of the molecule vessel, what happen? The gaseous molecules which are present. Okay, so what happened? The gaseous molecules, they have tried to achieve the volume of this vessel, volume of this container. Okay, let's see. The gas made of the molecule dispersed in the space in the container. So now, if you try to define the volume of these gaseous molecules, simply we can measure the volume of this container. Simply we can measure the volume of this vessel, and we can say that that much volume of the gas which is present here, that much volume of the gas which is present in this system. On what basis? Just simply on the basis of volume of vessel and volume of container. But actually what happened? The actual volume of the gas is this much. If you compress, the volume of actual volume of gas is this much. If you release the pressure, this gas, this molecule, they will try to occupy each and every corner. They will try to occupy, try to reach the all empty space which they are getting in the vessel and container. Okay. So how the volume of gas it will get changed, or the regarding the parameter of the volume of gas, or regarding the kinetic molecular theory. Actually, gaseous volume is this much, but if you provide the larger vessel, if you fill this much volume of gas into the larger container, definitely they will try to reach towards the that much volume of container or that much volume of the vessel. Okay, so how the gases they will show, or how the gases they will try to reach the volume of the container or vessel with respect or as compared to their actual volume. Second is the regarding their random motions and how the directions change. Let us see. This molecule is moving in the straight line. This molecule is moving in a straight line. This molecule is moving in the straight line. Okay, but what happened? As this molecule is moving in the straight line, this molecule is moving straight line. One situation it will come. This molecule and these molecules they will get hit. They will get attack on each others, and such types of the attack. The one molecule is hit on the another molecules. Is let us see here. This molecule is coming by this from this side in the straight line direction. This molecule is coming from this side in the straight line directions. But due to this attack, due to this accident, what happened? The collision is takes place. This is the molecular collision it takes place, and due to this, what happened? The direction of the molecule it was get changed. Okay, this is the one. Second is the when the molecules, gaseous molecules they form. Let us see. This gaseous molecule is moving in the straight line direction to the wall of the vessel. Again, this molecule is moving. This molecule is moving. When it will get form the collisions, or when it will get hit on the wall of the vessel, what happen? Again, their direction changes takes place. That is the collision with the wall. That is by the kinetic molecular theory of the gas. Let us see. The gas molecules are in the constant motion in all possible direction. This is the assumption of the kinetic molecular theory. In that assumption, what you have say that the molecules move in the straight line. We have say that the molecule, all the molecules in the gas which are show the straight line motion, And when the direction it will get changed on collision with the another molecules. Let us see, when the collision is takes place with the another molecule, what happens? The straight line direction it will get changed. And when the collision with the wall of the container also, the direction is takes place. So how the direction of the gaseous molecule is takes place, or the random motion is takes place into the gaseous state, that is the according to the kinetic molecular theory of gas. This is overall about the assumptions of the kinetic molecular theory of the gases. Okay, thank you.